So when we left off in our last video, we had said that weight and gravity are basically the same thing, the same force. We divided by lowercase m on both sides of our equation, and we ended up solving for the acceleration due to gravity, lowercase g. Now we can use this equation to solve for the mass of our planet. So the mass of the planet is represented by the capital M. So the first thing that we're going to do is swap both sides of the equation and rewrite it like this. So now we have capital M on the left side of the equation. Now we multiply both sides of the equation by r squared, and we get capital G, capital M equals lowercase g times r squared. And then we're going to divide both sides of the equation by capital G. So the mass of the planet is lowercase g times r squared over capital M. Sorry, capital G. And that's our equation. Sometimes we make mistakes. So capital M is equal to lowercase g times r squared over capital G. Okay, so here on Earth, the acceleration due to gravity, lowercase g, is 9.81 meters per second squared, approximately. And the radius of the Earth is 6,356 kilometers, which in scientific notation is 6.356 times 10 to the third kilometers. All right, you'll see that I moved the decimal point 3 places to the left to make that change. And then to convert this to meters, we just add 3 to the exponent in scientific notation. So we get 6.356 times 10 to the 6th meters. So we're going to use this information, the acceleration due to gravity here on the surface of the Earth, and the radius of the Earth, which is the distance from the center of the Earth to where we are all standing or sitting right now, approximately. And we're also going to use the universal gravitational constant to calculate the mass of Earth. So we say that the mass of the Earth, and by the way, that circle with the little plus sign in it, that is the symbol for Earth. Okay, so the mass of the Earth is going to be equal to 9.81, that's lowercase g, times the radius, which is 6.356 times 10 to the 6th, and we're going to square that, and then we're going to divide by the gravitational constant, which is 6.67 times 10 to the negative 11th power. So let's get our calculator ready. Okay, so first let's do 6, maybe it would help if you can see me push the buttons. 6.356 exp means times 10 to the 6th power, and then we want to square that. Multiply that by 9.81, and then divide that by the gravitational constant, 6.67 exponent negative 11. So we find that the mass of the Earth is 5.942, let's call it, times 10 to the 24th kilograms. Now, I'm going to look that up on the internet right now. If I Google the mass of the Earth, it says 5.972 times 10 to the 24th kilograms. So this gives us a pretty close representation of the mass of the Earth. So again, that's how we calculated the mass of the Earth, and we'll come back and use this to do some exoplanet calculations.